All right, hello everyone. Welcome to my channel. This channel is for educational purposes and particularly things that are obscure and esoteric that very few people know about, but they are of fundamental importance. And we are doing today video number 193 on the reciprocal system of theory from this guy named Dewey B. Larson. And Mr. Larson was working out his theory starting in about 1930 all the way up until his death in 1990. He deduced, or he first went through a process of induction, in order to arrive at his two fundamental postulates in about the late 1950s, and then worked backwards from there in a process of deduction. If this, then that, if this, then that, to arrive at a theoretical universe, one step at a time. And he goes through his whole process of deduction there in a talk that he gave called the Deductive Development of the Reciprocal System, which I have gone over in about 15 videos earlier in this series. So you want to listen to that if you want to hear how he developed this step by step, and how he creates a theoretical universe and then he matches it up with the universe that the scientists have come up with through a process of observation and measurement. And so he's creating a universe strictly from his theory. And the theory is basically that we live in a universe of motion. The universe is not made out of matter. It's not made out of energy. It's made out of motion. And motion is the relationship between space and time. And so space and time are not the container of the universe, but they are more like the contents of the universe. And space and time have a few properties that we're not accustomed to. One is their three-dimensionality, three or more dimensions, I would say. Larson calls that coordinate space, which we are accustomed to, coordinate space, XYZ coordinates. But there is also coordinate time, a three-dimensional time that we don't generally know anything about. And then there is what he calls clock time and space. Clock space we're familiar with. That is, the clock is always moving forward. It's always getting later and later and later and later. But space also has its clock aspect, meaning that things are getting farther and farther and farther apart. And so that is the progression of space, or the clock space. Space and time are both also come in discrete units only. There is no continuity of space and time. They come in little chunks. Those chunks are very little, but so that we can't really detect them unless we are really looking close. But nonetheless, space and time come in only discrete units, and if you have exactly 1 unit of space in exactly 1 unit of time, you have the speed of light. And the speed of light then is set up as the midpoint of this universe. Unlike Einstein's universe, where the speed of light is the maximum speed of the universe, in Larson's universe, the speed of light is the midpoint, or the null point, or the 0 point, or the origin, or even the ether of this universe. And there is an entire half of the universe that's moving faster than the speed of light, where the speed of light is actually the minimum speed of this universe, of the cosmic. Larson calls that the cosmic sector. And so in that cosmic sector, that is where you have the three-dimensional time and the clock space, the progressing, always getting further and further apart space. So in clock space, you have, in the cosmic sector, you have three-dimensional time and one-dimensional progressing space. And then in the material sector, the sector that we're familiar with, we have the familiar coordinate space, XYZ coordinates of space, and clock time, time is always getting later and later and later. Okay, so we already kind of have mapped out this world of the material sector, but on the other hand, we know very, very little about the cosmic sector. However, because of the reciprocal relationship between space and time, everything that's going on in the material sector, it's the exact same thing is going on in the cosmic sector, except that you have to reverse the roles of space and time. So what's going on in the material sector, all you do is flip the roles of space and time, and you know exactly what's going on in the cosmic sector. And so that process of extrapolation basically doubles our knowledge about the universe. And there are other ways to increase much further. And so as a result, Larson was able to use his theory to write books on physics, astrophysics, chemistry, astronomy, and including also economics and metaphysics, including philosophy, religion, and psychology. He's even got a chapter on dream interpretation. And then some of his followers, especially Dr. Bruce Perret, who also unfortunately passed on a few years back, has extended his theory into even more distant realms, such as cryptoarchaeology and time travel, or the possibilities of time travel, and things like path of initiation. All these things are potentials of the reciprocal system. And that's why one of the reasons why I like it so much and why I want to feature it here on this channel is that I think it can really help people to really understand a bigger picture of what's going on. Okay, now we are in chapter 13 of his book that is called Nothing But Motion. This book is primarily on atomic physics, and we are in chapter 13, which is called Physical Constants. And so now we normally, in science, in legacy science, they have certain constants that they use, the speed of light, the gravitational constant, the gas constant. There's all kinds of constants that they use. And Larson says that most of the constants that they use, especially in atomic physics, are what he calls fudge factors. They use these numbers just so that their equations balance out properly. But in Larson's world, a true constant is always really a unit or a multiple of units. And so in Larson's system, you really have three fundamental units that create boundaries in the universe. The first unit is that speed of light. That's 1 unit of speed, 1 unit of space in 1 unit of time. And that's the speed of light. That is the boundary between the material and cosmic sectors. And then also within both the material and cosmic sectors, there is a subunit that is called, in the material sector, it's called the time region. And in the cosmic sector, it is called the space region. And this has to do with the discrete unit postulate. When you have 1 unit of space is the minimum unit of space. You don't have space any less than that 1 unit. So if you are operating in an area that is less than 1 unit of space, you're operating only in a region of time. So that is the time region. Same with the space region. Inside of 1 unit of time, you only have space. So that is what's called the space region. And so those are the 3 fundamental units that comprise the boundaries. When you cross those boundaries, the rules basically invert. And there are a few other things that happen as well, but that's basically the rules invert when you cross those boundaries. Okay, we're going to let Larson take over here, and he just got done kind of deriving all of the different masses of the subatomic particles: electron, positron, neutrino, massless neutron, proton, also the mass 1 isotope of hydrogen, and the compound neutron. Okay, in the first edition, the relation between the natural unit of mass and the arbitrary unit in the CGS system was identified in terms of the gravitational constant. It has recently been pointed out by Todd Kelso and Stephen Berlin that the relation thus established cannot be converted to a system of to a different system of units, such as the SI or MKS system. This made it evident that the interpretation of the gravitational phenomenon on which the previous determination was based was in some way erroneous. An analysis of the situation was therefore carried out in order to locate the point of error. The invalidation of the interpretation of the gravitational equation has no effect on any other feature of the theoretical results that have been obtained from the reciprocal system, as described in this volume. Its sole result has been to leave this system of theory without a connection between the gravitational equation and the theoretical structure. Once the situation is viewed in this light, it is immediately apparent that the lack of connection between the equation and physical theory is not peculiar to the reciprocal system. Conventional theory does not identify the connection either. The physics textbooks find it necessary to admit this fact in statements such as the following. It should be noted, quote, "It should be noted that Newton's law of universal gravitation is not a defining equation like Newton's second principle of mechanics and cannot be derived from defining equations. It represents an observed relation," end quote. And I guess that is from a physics textbook. And Larson says that this is a theoretical discrepancy that conventional physics has not been able to resolve. But it is an isolated discrepancy, and it has been swept under the rug by assigning fictitious dimensions to the gravitational constants. It follows from this that the error lies in some interpretation of that observed relation that has been common to both conventional theory and the reciprocal system. Evidently, the developers of both systems of theory have misunderstood the true nature of the phenomenon. Here, again, recognition of the source of the difficulty points the way to the resolution of the problem. As brought out in the earlier chapters, one mass does not actually exert a force on another. Each is pursuing its own course independently of all others. But the results of the inward motions of two masses are similar to those that would follow if the masses did attract each other. These results can therefore be represented in terms of an attractive force on an as-if basis. But in order to do this, we must put the as-if forces on the same footing as real forces. A force can only be exerted against a resistance. Hence, when we attribute a force to the motion of one mass, we cannot also attribute a force to the motion of the other. We must attribute a resistance to the second mass. Thus, an as-if force, a gravitational force, is exerted against an as-if inertial resistance. In the previous discussion, we identified gravitation as three-dimensional motion, s to the third power over t to the third power, and inertia as three-dimensional resistance to motion, t to the third power over s to the third power. The product of the gravitational motion and the inertial resistance therefore does not have the dimensions of mass to the second power, as the conventional expression of the gravitational equation indicates. it is dimensionless. This is a situation in which the ability to reduce all physical quantities to space-time terms is very helpful. And again, what I didn't mention is that all scientific quantities can be reduced exclusively to space-time terms. So, when we say the universe is not made out of matter, it's not made out of energy, it is made out of motion. And motion is the relationship between space and time. That basically is really saying that both matter and energy are relationships between space and time, just like everything else. And so in this case, matter, as he said, is time to the third power over space to the third power. Energy is one dimension of that, time over space. And that he refers to as the resistance to motion. So the speed is space over time. The car is moving 20 miles per hour, 20 miles of space in 1 hour of time. Speed is space over time. The resistance to speed, which is energy, is time over space. Or you could think of it, Dr. Bruce Perret would always say, it took us 3 hours to move that thing 10 feet. 3 hours of time in 3 feet of space. Or what did I say? 10 feet of space. Okay, back to Larson. So he's saying here that the ability to reduce all physical quantities to space-time terms is very helpful. Instead of messing around with things like grams or, well, I guess that's primarily what is in the MKS system, meters, kilograms, seconds. The meters and the kilograms are space and time, or the meters and the seconds are space and time, but the kilograms reduce to mass, time to the third power over space to the third power. So that simplifies everything, and it also serves as a check. You can check your work when you use only space-time terms in the units. You can reduce everything to space-time terms, and it makes it very easy to check to see if your equation is all right. For example, you can take the E equals mc squared. Energy equals matter times the speed of light squared. Energy is time over space. Matter is time to the third power over space to the third power. And the speed of light, speed is space over time, but it's squared. So the speed of light squared is s over t times, or over s squared over t squared. And so when you multiply those all out, they are equivalent on both sides of the equation. So that is a valid equation according to the reciprocal system, at least in terms of the units. Okay, now it will also be convenient to examine the dimensional situation independently before taking up a question of the numerical values. The gravitational equation, as expressed in current practice of legacy science, is assigned the dimensions as follows: dynes centimeter squared gram per gram squared times gram squared times per centimeter squared equals dynes. I'm not sure exactly what that means, all of it. Can't remember what dynes are exactly. But reducing equation 13.1, that equation, to space-time terms in accordance with the relations established in Chapter 12, we have time, the quantity, time over space to the second power, times space to the second power, times space to the sixth power over time to the sixth power, times, that quantity times time to the sixth power over space to the sixth power, that you get that from g squared. G is grams. That's time over space, time to the third power over space to the third power, but then you square that. So you get time to the sixth power over space to the sixth power times 1 over space to the second power. And that equals time over space to the second power, which is force. So that is how he maps out this gravitational equation. In the light of the new understanding of the term, mass time, first mass times second mass, term as the dimensionless product of gravitational and inertial mass, it is now evident that the S6 over T to the sixth dimensions belong with the term rather than with the gravitational constant. And that is what is in the legacy science equation, is using that gravitational constant with those 6 powers. When they are so applied, the resulting dimensions of m1 cancel out as the true theoretical dimensions do. We can therefore replace them with the correct dimensions. As pointed out in the first edition, there are also 2 other errors in the customary assignment of the dimensions to this equation. The distance term is actually dimensionless. It is a ratio of 1 over n squared to 1 over 1 squared. The dimensions that are mistakenly assigned to this term belong to a term whose existence has not been recognized because it has unit value and therefore does not enter into the numerical calculation. Okay, we're going to stop there and start going over. We'll go back a little bit and go over this again slightly, but tomorrow. But in the meantime, have a great day, and thanks for tuning in.